हेलो एंड हाय फ्रेंड्स, माय सेल्फ सुब्रो रॉय और मैं आप सभी का अपने इस वीडियो में बहुत बहुत स्वागत करता हूं। दोस्तों, आज का जो टॉपिक है वो है कैरेक्टरिस्टिक्स ऑफ साउंड। दोस्तों, साउंड क्या होता है, उसकी क्या क्या कैरेक्टरिस्टिक्स हैं, इसके बारे में हम आज बात करेंगे। एंड वी ऑल वुड लाइक टू नो बेसिकली what the sound is all about. So friends, first of all, let us see what the sound is all about. The definition of sound. The sound is a compressional wave. Friends, as the definition says that the sound is basically a compressional wave. Secondly, the particles of the medium carrying the wave vibrate longitudinally. Friends, it is a thing to be listened carefully that the particles of the medium carrying the wave vibrate longitudinally in the direction of travel of wave, producing alternating region of compression and rarefaction. So friends, this is what the sound waves is all about. Now the second thing is how the sound waves are differ from light waves. The sound waves are basically the longitudinal waves and the light waves are transverse waves. So friends, as we see that the part in the longitudinal waves, there is a part which is the wavelength, the compression, the expansion, the source and the direction. And in the transverse waves we see the crust, the trough, and the distance between the two trough is the wavelength, the source and the direction. So this is the difference between the sound waves and the light waves. That is, sound waves are the longitudinal waves and the light waves are the transverse waves. Now friends, most of the time whenever we talk about sound, we used to talk about the wavelength and the frequency. Then as we see in a longitudinal waves, there is a wavelength. So what is the wavelength? Wavelength is the distance from one compressed zone to the next. It has to be, listen carefully friends, that the wavelength is the distance from one compressed zone to the next, is the distance wave travel during one cycle. This is the definition of wavelength. Now frequency. Frequency is the number of complete wave transmitted per second. So friends, this is what the wavelength and frequency is all about. Next, what is the relation between the frequency and the wavelength? Friends, as we see that the relationship is in front of us between the frequency and the wavelength. As we see that V is equal to F lambda, and V is the velocity of sound, it is in meters per second. F is the frequency in cycles per second or hertz, and lambda is the wavelength in meters. So friends, this is the relation between the frequency and the wavelength. So next is velocity of sound. Now the velocity of sound in air depends upon the temperature. As we see the formula, that velocity is equal to 20.05 under root 273.2 plus degree centigrade. It is in meter per second, and C is the centigrade, degree Celsius, and F is the Fahrenheit, where velocity is equal to 49.03 under root 459.7 plus F, that is in feet per second. So friends, we see that the velocity of sound formula, and after that sound power. Now sound power is measured in watts. It is independent of distance from source and independent of environment, whereas the sound intensity is watts per unit area. It depends on the distance. Next, friends, a well-known unit to all of us about the sound is decibels. Decibels and levels. In listening, sound expressed as decibels instead of watts. By definition, a decibel is 10 times the logarithm to the base 10 of a ratio of two powers or power-like quantities. The reference power is 1 pW or 10 raised to power minus 12. Therefore, Lw is equal to sound power level in dB, that is decibels. W is equal to sound power in watts. L log, that is equal to logarithm to base 10. And here is the formula for the sound power level in decibels. Next, friend, sound pressure. Now, what is sound pressure? Sound pressure level, the measurement of sound pressure level, how we used to do the measurement of sound pressure level. There is a formula. Sound pressure level is 10 times the logarithm of the pressure ratio squared or 20 times the logarithm of the pressure ratio. The reference sound pressure is 20 mu pascals or 20 into 10 raised to power 6 pascals. Therefore, LP is equal to sound pressure level in decibels. P is equal to root mean square sound pressure in pascals. L log, that is logarithm to base. And friend, after that there is a formula. LP is equal to 20 log P upon 20 into 10 raised to power 6. So friends, here is the sound pressure, and I would like to thank all of you to watch this video, and please subscribe if you like this video, and please tell me, please comment that if something new or something more you want from this video. Thank you very much.